Hello there. This video is for pre-calc Friday, May 8th. These are the ones that we did not get through in the class. So I'm just doing numbers 8, 9, 10, and 11. Okay, so number 8 is based on this one. The limit as x approaches 4 from the left is infinity. The limit as x approaches 4 from the right is infinity. The limit as x approaches 4 is therefore infinity, because as long as these two are the same, then that's the answer. But at actual 4, like doing f of 4 or something like that, there's no value. It does not exist. The limit as x approaches negative infinity, it's getting closer. There's a horizontal asymptote on the x-axis, so it's 0. And the limit as x approaches positive infinity, then there's another horizontal asymptote at -1, and that's -1. Okay? That was that, number 8. Number 9 is annoying because the graph is on the top of the next page. So let me see if I take the... Here. Let's see. Number 9. I'm trying to put it right here so you can see how you can. I'll have to go back and forth. The limit as x approaches 3 from the left. So as x approaches 3 from the left, it's going down. So it's going to be towards negative infinity. The limit as x approaches 3 from the right, it's going down. That right? So that's negative infinity. So this is over here, negative infinity and negative infinity, which means the limit as x approaches -3 is negative infinity. F of 3, there's no value at, oh, sorry, there is a value at f of 3. There's that dot right there. So f of 3 is 1. Okay, I almost missed it. And then the limit as x approaches negative infinity, that's y equals 2. There's a horizontal asymptote there. So we get 2 as x approaches negative infinity. And as x approaches positive infinity, it's also 2. So they are both 2. Over here and over here. Okay, 2 down, 2 to go. And then your delta math is going to be based on limits graphically, what we're doing now. Okay, number 10. Here we have the graph here. Nice, it all fits. The limit as x approaches 0 from the left-hand side. It's an open circle, but it's still 1. The limit as x approaches 0 from the right-hand side is negative infinity. The limit as x approaches 0, they're not the same, so it does not exist. F of 0 is -2, because there's that dot right there. If that dot was not there, it would be does not exist. The limit as x approaches negative infinity, it's going all the way up and up and up. That's infinity. And the limit as x approaches positive infinity, going all the way to the right, it's still going up. So positive infinity. Okay, and we just have one more, number 11, for a quick 5-minute video. This looks to be a sine curve. It goes on and on and on like that and never stops. So I'm assuming these arrows are just going to keep going on and on. The limit as x approaches 0 from the left is 0. The limit as x approaches 0 from the right is 0. So the limit as x approaches 0 is 0. G of 0 is also 0. But then here's the tricky part at the end. As x approaches negative infinity, it does not exist, because it's going to go up and down and up and down and up and down. So it does not exist due to oscillation. Like a fan, when you put it on oscillate, it goes back and forth and back and forth. That's why this one does not. And the same with as x approaches positive infinity, it's going to go up and down towards, up towards 1, down towards -1, up towards 1, down towards negative. It's just going up. So there's no limit because it keeps going. It keeps oscillating. So there you go. A little bit more practice on limits graphically. And so again, you have a delta math. The delta math is due Monday morning by 9 a.m. And then if you submit it within a day late, the next day you get 90%. And then after that, by the end of before the next Friday, you get 60%. So please be aware of the times. And I do not control it. For those of you who have been doing your little handing things on past 12 o'clock at night, but I'm not worried about it. I am taking the grade as it appears, so you must get it done on time. Okay, people, be good. Hope you're all well. Bye, and have a great weekend. Bye.